Oh, okay, thank you. Talk about the robotization in plant production. Especially, I would like to say something to horticulturalists from my viewpoint of the engineering. So we have done we have developed these right-side robots so far, transplanting robots, grafting robots, and cutting skin robots for seedling production. And plant management, we could do the robotic sprayer in greenhouse. Also, pre-processing and grading and packing can be conducted by automation systems in facility. However, this harvesting is not easy to commercialize. Very difficult to pick the one fruit by one fruit, some like the individual fruit picking. So let me explain these robots in this order. Now first, seedling production. You may know well about the transplanting robot, left one. The Dutch companies already commercialized like that. And that is 20 years ago or so. Also, right-hand side, grafting robot developed by some Japanese research institute, and some companies already commercialized and spread. Then, this is so quite easy to handle the by robot, because small size and uniform, quite uniform shape and size. So that's why it's possible to do by robot like that. Then in plant factory, some Kyushu electric power company already developed the left side. That kind of robot, transplanting robot, from seeding to transplanting and even harvesting operation would be conducted by a robot. Because you can see that rock wool is easy handling like this, and after harvesting, this is another robot, another machine that cut the root and even packing. This is measuring the weight and packing, also automated like that. However, let me talk about the fruit harvesting is not easy. The very first fruit harvesting robot was developed in 1982, just 30 years ago, by Professor Kawamura, who was my supervisor when I was a student at Kyoto University. And this is a very fast fruit harvesting robot, and consisted of 5 DOF manipulator, end effector, machine vision, and trapping device. These components are very similar with the current harvesting robot we are doing now. Then started with this robot, many researchers applied these technologies to many fruits and vegetables. Let me show you some of them. Cherry tomatoes, the normal size fruits tomato, and cucumber, lettuce. This is just an example, but looks not bad, but very slow compared with the human operators. The left top one has a 3D sensor too. So we can know the even obstacles. Then avoid the obstacles sometimes. It's possible, but 5 seconds or even 10 seconds are necessary sometimes. So not enough speed. Also very expensive. Some of them are 7 million yen, that is $70,000 or so. Anyway, so this kind of robots are developed in 1980s and the 1990s. Then this one, okay, this one was mushroom harvesting robot. This is the machine vision systems with lighting devices. And suction cup can suck up like that. Then before harvesting, just a twist, a little bit twist it and pull up like that. Yeah, that is possible to harvest it. However, same thing, very slow. Then after harvesting, the conveyors moving like that. Then cut the root and dropped into these containers.
Can you go to full screen?
Let me save the time because that is very long. Okay. Okay. The next would be this perilla leaf. This is possible to do grow in greenhouse like this. On tabletop culture, that is easy to operate for human operators. But this harvesting is not good. Is not easy. So this is you may know in Japanese cuisine sashimi, assorted with sashimi or some cuisine. Anyway, we tried using this. This is like tea leaf cutting machines, but many leaves are injured, so that's not cannot be shipped. Anyway, this individual fruit, individual leaf harvesting is difficult. So let me show you these difficulties on commercializing these harvesting robots. The first, very slow. That is 1/3 operation speed, compared with a human. Then expensive. That is 3 times. It makes a 10 times difference compared with a human. And sometimes we need changes plant training systems or cultivation methods. So that is systematize the production. So far, no commercialized harvesting robot. So that's why we are now adding some new role, that is the informatization, information accumulation and utilization those informations. Okay, the robots can give us a very precise information. When harvesting robot, when doing something, anything anyway, a robot doing some operation, they can give us 3D location of the product or harvesting time and date, also crop ID or fruit size, color, and defect. So those very precise information are accumulated in the memories, very big size memories. Then every year, every season, those data could be can be used for the farmers and for the consumers. This is let me this one. The harvesting is difficult, but sorting or grading, packing are possible by robot. This is that perilla leaf sorting. The manual harvesting leaves, the bundled leaves are this picked by this robot, one by one like that. Then we can measure the size and the shape. Then based on this information, these several robots are sorting like that. So this is okay. This already commercialized by our company. Then grading, packing, after harvesting tomato fruits. Okay. Let me introduce these movie files. This was introduced in some Japanese broadcasting program about this fruit grading system with traceability database. Some place in Japan, He's a typical farmer who is growing tomato fruits like that. Very beautiful. Maybe not big difference from your countries, from your areas, tomato growing. In the morning, farmers harvest by manual. Then he's a farmer. Then he brought all fruits by containers like this to the facility. This is a grading facilities. Then you can see, this is a robot, grading robot, rotating the fruits, for acquiring the images. Many cameras, 16 cameras installed in this robot. Then this white box is near-infrared spectroscopy, which can give us internal quality such as sugar content. Even sugar content was measured. Then all data is accumulated, stored in this RFID installed in this each carrier. Then based on the data, they are sorted like that and packed in the box. Same size, same color, same quality fruits are packed in the same box. Also by robot. So many robots are working in this. Very, very few people, few operators are in this. Only in this is a robot's brain, the computer room. Then anytime you can check these tomato fruits and data and this farmer today, morning farmer can check today's score. Or how many fruits, how many medium size, small size, and grade A, grade B, grade C. I could make money, something like that. Then this facility can issue this product ID. Then once consumers got this product ID, then typed in the computer from anywhere, from US, from Japan, anywhere, you can get many data. Sorry, this is all Japanese, but those tomato data are shown in the computer. This is a typical traceability database with robot. Then this kind of robots are now spreading in the East Asians, not only Japan, Korea, and Taiwan. Even China is now interested in this. Then let me talk about this history, agricultural robot research histories. Since 1982, Professor Kawamura started harvesting robot. This first 10 years, we did adoption of industrial robots to agriculture. Then we investigated robotic mechanisms based on the plant properties. Then we could commercialize the seedling production robot. Then second stage, the next 10 years, we tried to do this fusion, technology fusion between horticulture and engineering for develop the fruit harvesting robot. Yeah, actually we could do this, but couldn't commercialize because slow and very expensive. Then third generation agri-robot, the third, we utilize the information. So then we could commercialize the fruit grading robot. Then now we are now struggling. What kind of way, which way is appropriate for the next generation robot? In vertical farming, probably some functional substances, some vegetables or fruits could be, I guess, can be grown. So we can do this human health-oriented robot by sensing those functional substances in the plant. Also, we have to consider supporting the aged producer and environmental conservation. So now I can say agricultural robots' roles are now diversifying. But today, let me talk about more about this not commercialized yet, this harvesting robot. To do that, we need more fusion between horticultural and engineering approaches, I think. From my viewpoint, this is my opinion, from the engineer's viewpoint. First approach, horticulturist approach, I wish, the variety selection for robot or breeding, but the breeding sometimes take time. So maybe variety, if possible, for varieties, it's just a selection. Then for this, simultaneous maturing, variety. That means, for example, tomato fruits. Hopefully 1 week at the time, 1 week, all fruits are matured, turn red. So we can harvest the whole cluster, fruit clusters. Okay, then we need a longer peduncle. Sometimes, sometimes we cut that robot cut the main stem. That is very dangerous. Also, and appropriate fruit size. Yeah, very small, sometimes a big one, and appropriate size and number is there for robots. Also, some, for example, orange trees. Some orange trees taller than 2 meter, 3 meter. That is not good for not only for robot but also human. If we develop the robots, that very long manipulator necessary and very slow and very expensive. That is the first approach. This is we can enhance the biological potential. Then second approach I wish is the plant training system cultivation method change for robotic harvesting, robotic operation. That is separate fruits from leaves and stems. So this is good for robots. And same position, same height is okay. Same height, grow and fruits grow. That is easy for detect, easy for harvest. And some another operation, additional operation for helping robot might be good. For example, leaf removing before harvesting. That is to be very good. No obstacles and no hide, no hidden, no fruit hidden by the leaves and stems. So this is, I can say, enhance the physical properties. This is one of the examples. Professor Jean Jacquemin, sitting Rutgers alumni here, they invented this single truss tomato production system. This is very easy for robot operation. And following that, some Japanese researchers do this. See, all same height fruits grown. Then I tried to, now I'm trying to do this developing, harvesting robot, whole cluster harvesting robot. If the fruits matured together in one cluster, that's easy like that. And then very much, efficient. And this one is another bar and is a set. Then fruits clusters hang down from that. And we tried to do this inclined trace training system for cucumber and grapes. This is common in Japan. Then this robot is working in the night time on tabletop culture. Actually, it is easy for harvesting. Then in the morning, during the night time, this harvest. Then in the morning, ready to ship. Then final approach, chemical control. I would like to, a horticulturist. Number one, number two is same thing. Number three, hopefully, this joint easy detach. Make some chemicals makes easy detach before harvesting. Just a robot, just a touch, then easily harvested. Something like a dream, but maybe I'm not sure it's possible or not. And yeah, as conclusion to develop harvesting robots for practical use, that we have to conduct the challenging the development of cheaper and higher efficient robot by engineering approaches and adapting diverse plants or complicated properties solved by engineering approaches. Then in standardized plant conditions with variety selection, training systems and chemical controls by horticulture approaches. Those, both approaches are necessary, especially morphological plant feature change such as separation from fruits and uniform shape and easy handling by biological, physical, and chemical methods very, much more discussed. Thank you very much.
Thank you very much. Thank you. Is there a secret to making this thing? All right. Are there any questions? Yes, here we have one right here.
Could you take a guess at how many millions of dollars have been invested in your project since 1982?
How many what?
How many millions of dollars since 1982 in this effort?
How many $1 million spent for this? Yeah, we did many kinds of robots. So, yeah. I've never considered about that so far. Hey. Yeah, anyway, so usually we need the 10,000, average 10,000 in a year for one robot development. 10,000 per year, per one robot. $10,000.
We have a question in the back there.
Fascinating videos. Are they available online anywhere?
How many what?
Are your videos in your presentation available on the internet?
Some of them are available. Yeah.
Can we make those available to the? Okay, good.
He's okay with it.
Great.
Mm-hmm.
Sanjeev, yep, go ahead.
So Naoshi, I work in robotics, but I'm asking a question. Why are robots like this so slow?
The question is, why are robots like this so slow, from someone who works directly with robotics?
Yeah. That is improved. But we even going so, that is depends on the motor and some mechanism. Okay, some that engineering part. But also we have to more improve the machine vision systems and some artificial intelligence part. But mostly mechanical part would be problem. Yes, we have to.
We have one more time for one more quick question, and then you'll grab the microphone.
Sorry, I had a question about the human aspect. So, what point do humans become more efficient than the robots? You pointed at some of those moments when it was actually the harvesting. So, but do you have an understanding from what you've done from the